Hi everyone, welcome to my channel. Today we're just going to discuss about the transportation problem and precisely discuss about the northwest corner method, okay? So let's just move on. So it's a special kind of linear programming problem. Note the word special, okay? Because it basically deals with the minimization problem. Okay, so transportation problem is similar to the simplex method, but there's a lot of difference in that as well. In simplex method, you'll be having a lot of resources, whereas in the transportation problem, you'd be dealing with only one particular resource. And in simplex method, the time would be more comparatively. The time to solve is more, whereas in the transportation problem, the solution comes in a blink of an eye. Okay, so LPP is solved using the simplex method, whereas the transportation is solved using its own algorithm. Okay, the transportation algorithm, and that's how. Let's just see how it's solved. So the solutions to solve are the basic feasible solution and the optimality test. Let's move on to this. And the properties of basic feasible solutions are the allocation must satisfy the following constraints. And there are three constraints out here. One is the availability constraint, second one is the requirement constraint, third one is your non-negativity constraint. Imagine you being the owner of your company and you're having 5 employees working under you. The client demands a work of only 2 employees. Client side becomes the requirement constraint. The availability is 5 and the requirement is 2. So the next is actually proportional to both of the above points. Okay, so imagine if the client demands 15 of them and you've just got only 5 of your employees. So probably you would reject him beforehand because you only have 5 of them and your availability is lesser than your requirement. So there is a minus 10 constraint out here. Minus 10 employees are there. That's not going to be possible. So that's why it's always non-negative. It always deals with the positive value. Okay. Now the total number of allocations is equal to m plus n minus rho, where m represents your number of rows and n represents the number of columns. Okay. The column values and the row values. So to satisfy the equation, you have to make sure that your availability constraint equals your requirement constraint, and technically it's called as the origin capacities and the destination requirement. Okay, so the availability constraint is your employee and the destination requirement is from the client side. Okay, so to solve the basic feasible solution, we use 3 common methods. So one is the northwest corner method, least cost cell method, and third one is your Vogel's approximation method. Okay, in this video I'll be covering the northwest corner method and probably we'll be covering the other 2 in the next videos. Okay, so now there's been a problem out here and let us just solve this. Okay, so the number of rows out here is 4 and the number of columns out here is 3. So 3 is less than 4. So number of columns is less than 4. So we are gonna adjust it. So how do we adjust it? You're gonna add a dummy column in this one. So just write it separately. I'm not gonna write A, B, C, D and all those things. If you need it, you'll be writing it. You must describe it as you're gonna write exam paper. So the summation of B is equals 29 because that represents your column value, and summation of D equals 23 represents your row value. Okay, so 4 equals 4, and to make that you're gonna add a dummy column out here. And note the 6 out there. This 6 comes by minusing these two. 29 minus 23 becomes 6. And so you're going to add a dummy column and then add 6 out here. Okay, that would make sure that the sum, if you want to add all these things, you could also comment me if I'm wrong. Okay, so after adding this, you just go on. Now make sure that you are adding the value 4 at the topmost right corner. Okay, so after putting this, see this. Okay, after putting this, you're gonna just go on to the next, and just make sure that you're gonna allocating everything in the northeast side so that it will be easier for you to enter the values in the northwest side. Okay, now this is called the northwest corner. Okay, this is the north, and this is the east and west, and this is your northwest corner, okay? And that's how you'd probably say it as such. Now you're gonna just compare the values, both of them, okay? Northwest part is that one, and the corresponding row and column has now been shown, and write the smallest number, okay? Write the smallest in both of them, okay? Requirement or your availability, just make it this way. It'll be simple for you. Write the smallest number, cancel both of them, and minus this number, okay? Negate with this number and this number, as well as negate this number and this number, okay? So after putting this, you're going to write 10 minus 7 is 3 and cancel the corresponding column, okay? After this, your focus must go in this, and the northwest corner part is actually considered as this one, okay? So after that, you're going to just go and consider this and write the value of that, okay? After writing it, you need to just specify the other value, which is 9, okay? 12 minus 3 is 9, and make sure you have entered the value 3 out here, and then go on, cancel the particular row. Now your focus shifts, and then you're gonna cancel the particular row and cancel the particular column value as well, okay? Mark the value and then cancel it. Now the value becomes 1 here, okay? Now consider this corresponding thing. The focus shifts out here. The northwestmost corner becomes this, and that's how you're going to solve it. 5 and 1. 1 is the smallest number. Cancel both and write the value 1 out here. 5 minus 1 is 4. Write the value 4 out there, and then strike the corresponding column. Now just go to the next part. The northwest part becomes this one, and now repeat the process and cancel here. Both of them are equal. Cancel both of the values. Don't forget to write the value out there. Cancel the column and cancel the row as well, okay? So now our focus shifts, so this is where it is, and now you're gonna cancel this out, write the value out there, and of course 6 minus 6 becomes 0, and of course 0 minus 0 is again 0, and that's how it is. Cancel everything, and now you're gonna separate all these things, okay? Separate all these things, and don't write the availability and demand here, or the requirement, okay? So I'm gonna just list down all these things in paper. Make sure that you're not gonna strike off so that you're not able to find the number. Can you see this? The striking is quite messy, and probably you might not be able to see the numbers as well. I've not written the availability and all those things. So let us just consider this. What you're gonna do is you're gonna get the value out there, you're gonna multiply it with this one, and you're gonna add all the other values and do the same, okay? So what you're gonna do is multiply all those values and add it with the other cell, okay? Add it with the other cell and multiply it, and then that's how you arrive at the answer, and that becomes your total cost, okay? Thank you for watching, everyone. Thank you.